The overall goal of this two-dimensional gel electrophoresis, coupled with mass spectrometry procedure, is to separate and identify human pituitary adenoma tissue proteome.
This method can help answer key questions in the proteomics field, such as high throughput identity of proteome, larger scale identity of low abundance proteins, and discovery of protein speciation, protein 4, and protein species. The main advantage of this technique is that two-dimensional gel electrophoresis is easily coupled with high-sensitivity mass spectrometry to identify proteome, especially low-abundance proteins, protein speciation, protein 4, and protein species. The implications of this technique extend toward pituitary adenoma therapy because a key protein 34, protein species, or protein pattern is useful in patient diagnosis. Visual demonstration of this method is critical, as the two-dimensional gel electrophoresis steps are difficult to learn because it is time-consuming, labor-intensive, and involves several experimental tricks.
To begin this procedure, add 250 microliters of a previously prepared protein sample solution to each slot of a 13 cm IPG strip holder. Place an 18 cm IPG strip gel side down onto each protein sample solution, taking care to avoid bubbles. Then, add 3 to 4 milliliters of mineral oil to cover each IPG strip. Next, assemble each IPG strip holder into an isoelectric focusing system, with a pointed end on the back plate and the square end on the front plate. After rehydrating the IPG strips for 18 hours at room temperature, set the IEF parameters on the isoelectric focusing system with a total runtime of 7.5 hours and 36,875 volt-hours. After IEF, take out each IPG strip from the isoelectric focusing system and remove the excess mineral oil with an insoluble paper towel. Then, wrap each strip in a sheet of plastic wrap and store at -80 degrees Celsius. To cast a 12% page gel, add double distilled water, 1.5 molar tris hydrochloric buffer, 40% acrylamide bisacrylamide stock solution, 10% ammonium persulfate, and TEMED to a beaker. Mix the gel solution gently, taking care to avoid bubbles. Gently pour the gel solution into a multi-casting chamber up to the expected gel height of 19 centimeters. Immediately add about 3 milliliters of double distilled water to the multi-casting chamber to cover each resolving gel and allow each gel to polymerize for about 1 hour.
This step is very important to prepare a high-quality SDS page gel. An equal volume water must be immediately added on the top of each gel.
Prepare 2 liters of electrophoresis buffer. Then, add the buffer to an electrophoresis separation unit buffer tank. After removing the focused IPG strips from the freezer, place them in a plastic vessel containing 1 milliliter of reducing equilibrium buffer and a trace of bromophenyl blue, and equilibrate them for 10 minutes with gentle rocking. After removing the reducing equilibrium buffer, add 4 milliliters of alkylation equilibrium buffer and a trace of bromophenyl blue to the IPG strips and equilibrate them for 10 minutes with gentle rocking. During gel equilibrium, disassemble the multi-casting chamber and remove the prepared resolving gel cassette. Rinse the gel cassette 3 times with double distilled water. Then, remove excess water from the gel cassette with an insoluble paper towel and place it in a gel stander. Following this, rinse the equilibrated IPG strips with electrophoresis buffer and remove excess liquid on each IPG strip surface with an insoluble paper towel. Place an IPG strip onto the resolving SDS page gel, allowing the IPG strip's plastic side to contact the longer glass plate with the pointed end to the left. Now, quickly add 3 to 4 milliliters of hot 1% agarose and SDS electrophoresis buffer to seal the IPG strip on the top of each SDS page gel, and place the top side of the IPG strip down on the top of the shorter glass plate, taking care to avoid bubbles.
These steps are very important to seal the IPG strip to SDS page gel. The hot agarose solutions must be immediately added, and the IPG strip must be immediately placed into the top of the SDS gel.
After polymerization, insert the assembled gel cassette vertically between the plastic gaskets in a vertical electrophoresis system. Place the top of the gel with the IPG strip next to the cathode. Next, adjust the level of electrophoresis buffer to immerse the gel cassette by adding the appropriate volume of buffer to the electrophoresis system. Connect and set the power supply in constant voltage mode and run at 200 volts for about 370 minutes while monitoring the die. After the run is complete, take the gel cassette out of the electrophoresis system and gently remove the gel from the gel cassette, taking care to avoid tearing the gel. Carefully transfer the gel to a tray containing 250 milliliters of fixation solution and gently shake the gel for 20 minutes. Following this, discard the solution and add 250 milliliters of 50% methanol to the tray. Then, gently shake the gel for 10 minutes. After shaking the gel in double distilled water, add 250 milliliters of sensitization buffer containing 0.02% of sodium sulfate. Gently shake the gel for 1 minute. After shaking the gel twice in double distilled water, add 250 milliliters of silver reaction solution and gently shake the gel for 20 minutes. After shaking the gel in double distilled water, add 250 milliliters of development solution and gently shake until the desired staining is obtained, which is typically 1 to 3 minutes. Now, add 250 milliliters of 5% acetic acid to terminate staining and gently shake the gel for 10 minutes. After shaking the gel in double distilled water, add 250 milliliters of 8.8% glycerol and store the gel at 4 degrees Celsius until analysis. A reproducible and good two-dimensional gel pattern of NFPA tissue proteome was obtained from gel electrophoresis, with approximately 1,200 protein spots detected in the two-dimensional gel map that were mainly distributed within the area of pH 4 to 8 and mass 15 to 150 kilodaltons. A total of 192 redundant proteins were identified from 141 gel spots out of 337 analyzed gel spots in the MALDI MS-PMF analysis, and no protein was identified in the remaining 196 spots. Staining with Kamasi blue yielded a reproducible and high-quality two-dimensional gel pattern of invasive NFPA tissue proteome and approximately 1,100 protein spots detected in a two-dimensional gel map that were mainly distributed within the range of pH 4 to 8 and mass 15 to 150 kilodaltons. An average of 1 protein per spot was identified with MEL-D-TOF-TOF MS-MS analysis, whereas many proteins in each corresponding spot were identified with LC-ESI MS-MS analysis. This data clearly demonstrates that each two-dimensional gel spot contains many proteins in the complex human cancer tissue proteome.
Once mastered, this technique can be done in 32 hours for two-dimensional gel electrophoresis if it is performed properly. While attempting this procedure, it is important to remember to follow the steps exactly according to the protocol. Following this procedure, other methods like stable isotope labeling can be performed in order to answer additional questions like the quantification of proteins or protein species in a protein. After its development, this technique paved the way for researchers in the field of proteomics to explore larger-scale, low-abundance proteins, post-translational modifications, protein speciation, protein species, and protein 4 in model organisms, patients, and organ systems. After watching this video, you should have a good understanding of how to perform two-dimensional gel electrophoresis coupled with mass spectrometry, achieve a good and reproducible two-dimensional gel electrophoresis pattern, and identify many proteins in each spot. Don't forget that working with SDS, acrylamide, and TEMED can be extremely hazardous, and precautions such as wearing plastic gloves should always be taken while performing this procedure.